So hello guys, my name is Sandip. I'm a physics faculty at AskIITians. So today we are going to start a very good chapter, very interesting chapter you can say, right? Which is called as the laws of motion. Okay. So laws of motion means obviously, actually the better name for this we can say is the Newton's laws of motion, right? It used to be Newton's law, but nowadays it just comes like this. Right? So it is Newton's law of motion. So everybody knows the Newton, right? So I'm not going to repeat that story, that how the apple actually falls on Newton head and then how we discovered we can say, how we studied that gravity thing, right? Okay. So here on the screen you can see that some planet is trying to attract its moon with some force. It's trying string to that moon, we can say, right? Yeah. Actually, we do know that that is not the case in case of moon and planet, or we can say planet and sun. So how that planet is rotating around the sun, or that moon is rotating around the earth, right? Newton studied all those things, right? So we only know that apple fall and that Newton said, and that's it. No. But he studied a lot more than that. Using that gravity thing, he studied that how planets are revolving, how the moon is revolving around the earth, and all those concepts, right? In the macroscopic physics, we can say. Now, what is macroscopic physics? We can say macro and micro. There will be two types of the physics you are going to study. Right? So in macro, we are going to study all these motions of the planets and or bike, we can say, velocities, acceleration, forces, all those comes under the macroscopic thing, right? So Newton studied the macroscopic thing, obviously. And what is micro? Micro means you can consider that protons, electrons, neutrons, right? Quantum physics, we can say. So nowadays, a lot of scientists are working on that theory, quantum physics, or quantum mechanics, we can say, right? So we already know that all how the planet revolve, etc., etc. But what is happening inside the atom? Yes, we do know that yes, electron is moving around the nucleus. Nucleus has that proton and neutron. But what else is going inside that? That also nowadays scientists are studying. Okay. Anyway, we will come back to our laws of motion chapter. So we are going to study the macroscopic thing, right? Not the microscopic thing right now. So in macro, obviously how this motion, laws of motion means what? So you already have studied the initial velocity, final velocity, then how to calculate the distance, displacement, how to measure the height of the building. You must have studied already like that, right? So if we do know that, now in this chapter, in the laws of motion, right, we can say in the laws of motion, we can actually going to study the cause of that motion, right? Why this motion happens, okay, like that, and why that forces acting on that and etc. that we are going to study, okay. So let's see what we are going to cover in this session. So first of all, we are going to see what is force. What is force actually? Then what are the balanced and unbalanced force? So force, we already know that gravitational force, you can say, that is the basic of everything, right? That apple falls on the Newton's head, and etc. and etc. You know the history, right? Then what are the balanced and unbalanced force? Now this is an important thing. What are the balanced and unbalanced force, and why the motion happens? Whether it is because of balanced forces or unbalanced forces, we are going to see that. Then what is inertia? We'll see that what is inertia. In first law of motion, there are actually three laws of motion, right? So what are those laws are about? In today's session, we are going to see the first law, obviously, and then we can say in our next session we are going to see the second and third law of the Newton. So I know that you must have heard all the laws actually. Anyway, we are going to go in deeper into that, right? An introduction to momentum, right? So again, this is a new term now. We will see what is momentum also, right? Okay. So first of all, let's consider a very small example, right? Suppose you and your family are going on a vacation, right? You have a very nice car, right? So let me draw one car here. Okay, sure. So your family is going on vacation like this, and now suddenly we don't know how, but the car broke down, right? The car broke down. What will happen? Obviously, father will ask you, let's say this is your car, okay? This will be better car, right? Bigger car. Yes. So what will happen? Your father will ask you to go and push the car, right? To start, or you have to at least take that car towards the garage, right? So you and your brother are in the car. Obviously, your father cannot go and push the car. Why? Because someone needs to be on steering wheel, right? Okay. So now consider your brother goes towards end back of the car, we can say. Right? Car is becoming very large here. Okay, like this. And he started pushing, right? Now you also came out of the car and started pushing from this side. Okay, so what will happen, right? Will that car move or not? No. Why not? Because you are actually applying the opposite force on the car, right? So what you can say that you are actually applying the opposite force on the car, and therefore that car will not move, obviously, right? So what you have to do actually, your father will tell you that don't push it from this side but go towards the back and try pushing the car with your brother, right? So now you went back and pushing the car now. So one thing very important that we understood from this example is the direction is important here. Direction is important in this case, right? So where you are applying the force is also important for the motion of the car. Okay. So then now consider actually what you are doing in this case. You are pushing the car. Can we say you are pushing the car? So let's say, can I say force is a push? Can I say force is a push, right? Yes. Now consider that obviously car is very heavy. You can see it's a very big car, right? Actually, now let's know the little bit of correct diagram of the car. Right? It's not looking really good. So let's see. Draw the car here. Okay, I think now it's look good. Right, so this is the window here, vacation car, you can say. Okay. Now, as a car, you can see is a very big SUV, let's say. So you both were not able to push that car, right? So what you will do? Obviously, you have to take it to the garage, right? So, so you are going to call a, let's say, tow truck. What is tow truck? truck is something like this, which is going to pull your car using the string or cable connected to this car, and it is going to pull your car towards the garage, you can say, right? This tow truck. Now, what this tow truck is doing? Tow truck is also uh, pulling. Can we say tow truck is pulling? So in both the cases, when you were actually pushing the car, or the tow truck is pulling the car, in both the cases, what you are going to do? You are actually applying the force. So tow truck is pulling and you are pushing, right? Simple. So can I say that force could be push or pull? Very simple. So this is a very simple, small definition of the force, we can say, right? Yes. Okay. Then let's see the definition: the push or pull, right, which can change the state or shape. Okay. Okay. Just a minute. Okay. So as I was saying, yes, these are some examples of the forces where there is a push or pull, you can see, right? Okay. So as we have already seen in the previous example that force is what? Force can be push or pull. You both were pushing, right? And that tow truck was pulling. Okay. So this is how we can see. Now here also we can see some examples. This person, what this person is doing? This person is trying to push that block towards the right? And yes, so can we say yes, he's applying some force? Let's see what this guy is doing. He's trying to pull that block up, right? He's trying to pull that block up. Similarly, this person is also carrying that block towards the chair, right? So that person was carrying the block and keeping on the chair. Can I say he's also applying the force? Yes. What about this horse? What is doing? He's running. Is he applying the force? Yes. Where? I am not able to see any push or pull there. Yes, he is actually, you can see, with the help of the legs, that horse is actually pushing the ground back. Right? What we can say, that the horse is actually pushing the ground back. Therefore, he is actually able to run. So important thing to notice here is that another force is also there, which is called as friction, right? And that friction is actually again pushing that horse back. Therefore, he is able to run. So just that is action reaction forces. We know that that comes from the Newton's third law. But right now, just consider that horse is pushing the ground back, right? Then the persons are pulling. This person is pushing. These two are pulling the block, we can say, and keeping it on the chair, right? So this is the simplest definition of the force, that a push or pull which can actually change state and shape of the body. State means what? What is the state? First of all, you can see that this block was at rest, right, on the ground, right? So that is the state of rest, we can say. Okay. So if it is at state of rest, then you can see that he's changing the state, right? Now, obviously, when he was actually carrying that block, he was moving that block, right? So that block is in motion, we can say. So there is a change of state. Then, can you change the shape of the body, right? So suppose you apply the forces here. Consider what example we can consider here. So let's say You can take the example of, let's say clay. Clay means clay or mud, you can say, right? That clay material is, we can actually bend that, we can force those material to prepare the different toys or etc., right? So we can actually change the shape of the clay using the forces, right? So obviously, so force could be could change the state or could change the shape of the body. Okay, this. Then now let's talk about balanced and unbalanced forces. So what are the balanced forces and what are the unbalanced forces? Now here you can see the simple example of, let's say, seesaw, right? Yeah. So for seesaw, you already know that how the seesaw works. Consider if you and your friend are going to play the seesaw, and let's say you are of equal weight, that seesaw will not go anywhere, right? It will not move. Why? Because it is balanced. Why balanced? Right? Because when you are sitting on that, let's say, seesaw like this, right? You are actually applying the downward force, which is equal to your weight, right? Also, if your friend is sitting here, he's also applying the force, right? Downward force like this. If your weight is same, obviously seesaw will also have that weight like this. Okay? So if you're both the weight is what? Weight is equal to mg, right? You must have studied that somewhere. What is mass? Mass and weight are different things. Now remember, when we say mass is 50 kg, or normally we say, right, our weight is how much? Let's say 40 kg or 50 kg. But it's not true actually. Your mass is 50 kg. Weight is a different thing. Weight is a mass into acceleration, that is 50 into 10, or you can say 500 Newton. Right? So your weight is actually 500 Newton. Okay. So now, when you are sitting there, you are applying the force which is equal to your weight, that is mg, right? Let's consider 500 Newton. If you both are of 50 kg, 50 kg, 50 kg, what you can say, your weight will become 500 Newton. Both, if the both of you have the 500 Newton weight, that seesaw is not going to move. Why it is not going to move? Because now, because we can say it is perfectly balanced, right? So both the forces acting on that uh, plank or seesaw is same, right? Same thing is here we can see on the in the animation, right? If the both the blocks are 500 500, so they are applying the force of 500 Newton downward, right? So seesaw wall will not move. So when you increase the mass of the one of the block, let's say to the 700, in second case you can see 700, then yes, it is going to change, right? Now consider if your weight becomes so 40 kg, right? If your weight is 40 kg and your friend's weight is 50 kg, what will happen now? This weight will be 400 Newton. This will be 500 Newton. So that person will go down, right? So seesaw will, we can say it will go down on from one side. Whichever have the maximum force, maximum weight, that end of the seesaw is going to go downward, right? So we know that part. Okay. Now, so these are the balanced and unbalanced forces, we can say. So it is not necessary that if the forces are acting on the body and it will move, right? Because you can also consider one example. Suppose this is the door of your room, right? And you suppose you want to open your friend comes and knocks on the door, right? Let's say if you want to open this door and you tried pulling that door towards itself, and your friend is pulling that door, let's say from another side, like this, what will happen? Again, you can say the forces will be equal, right? If the forces are equal, that door is not going to move anywhere. Okay, so this is what we can say. So these are called as the balanced force. So even though there are the forces acting on the object, it is not necessary that it will move, but those forces should be equal forces, obviously, right? So when we say equal and opposite forces are acting on the door, then what we can say, that it is a balanced force, right? Body will remain in the equilibrium, it will not move. If unequal forces are acting, we can call it as unbalanced force, right? Unbalanced force means obviously that body is going to move. Obviously, suppose consider now you apply the force because of both hands. Now more force you apply on the door, that door will get open, right? Very easy to understand. Then it we can see there are double force there, so obviously door will get open. So only when you apply the unbalanced force, then only we can say object will move. Okay, so this is about the balance and unbalanced force. Okay, now let's see. Yeah, laws of inertia. First of all, let's see law of inertia, or we can also call this as Newton's first law. Okay, so there are three types we can say, right? Inertia. So first of all, let's see what is inertia. Inertia means what? It is the inability of body to change its state, or you can say it is something like that. Let's take an example. Consider if parents told you to study, right? Teacher says do study, do your homework, right? But you do it, no, right? Why? Because you have the inertia, you don't want to do it, right? Similar to that, you can say, right? This all the objects have some inertia, they don't want to change, they don't want to leave their state of rest, they don't want to change their state of motion. If they are in motion, they want to be in motion. Now here let's talk about the inertia of rest. Means if any object is in inertia, that body don't want to get into the motion, right? Here now here very nice example is given here, that truck, we can say big truck is there, like a tow truck, right? But tow truck actually uses the cable to pull the car. Here the truck is taking the car with the itself, right? But what is happening normally, whenever on the road you see something like that, that bigger trucks are carrying the small vehicles or small cars, then we can say that those are tied with the cables, right? Those cars with are tied with the cables, right? But here you can see that car is not tied with the cables, it is free, right? Maybe they have done some mistake here, right? They forgot to tie the car to the tow truck, right? So what is happening, the truck started in the motion, but our car, white car, and it is similar to you. You don't want to listen to anybody, right? You don't want to do your homework, you don't listen to parents, you don't listen to teacher, right? Similar to that, car is also similar, right? Car don't want to listen to anybody, right? It's car says I want to stay at the rest. Simple. Okay, so this is what happens, and when that truck actually moves, car doesn't move, right? Now again we can say, oh, does inertia dependent on what? Is this inertia or inability of body, right, to change its state, we can say, is dependent on what? It's obviously dependent on mass. So remember, inertia is dependent on the mass, we can say. Okay, so if you consider that car has a bigger mass, now consider one cycle is kept on that truck. Do you think it would have stayed like that? No, it would have moved with the truck, obviously, right? But because the mass of the car is very high, therefore it has a high inertia, right? Again, it is we can relate it to you students, right? Some students don't do homework if parents told repeatedly, but some are there, some are good students, right? So our match is a good, right? Yeah. So you students actually do homework. So what we can say, your inertia is less, right? Inertia is obviously not good, right? Okay, because we have to do homework. And inertia of those guys who don't do study, whatever people, whatever parents say or teachers say, we can say they have very high inertia, right? Like that. Similar, if the mass of the object is very high, inertia will be very high. And if the mass is very small, then we can say inertia is also small, right? Here you can see the second example here, that I think car is moving forward and the cat is sleeping on the car, right? Okay, so that cat is at rest, we can say, but cat is at rest with respect to what? With respect to car. Now imagine what will happen to that cat if driver supplies the brake suddenly, right? What will happen? That car will fall back, right? How that is happening? Because that cat get the push. Why? Because car is in motion, right? So can we say cat is also in motion with the car, right? So when car suddenly applies the brake, that cat don't want to lose the motion. We can say inertia of the motion, and it will fall back, right? It's like that. So this is the inertia of the race, we can say. Okay. Then inertia of the motion. Now let's see what is the inertia of the motion. So we have seen if any object is at rest, it does not want to get disturbed. It don't want to be in motion. Similar thing is for inertia of motion. So uh, if consider the cycle is in motion, right? So it will never stop. That is what the law says, right? Inertia of the motion. Here you can see that ball is moving. Consider if you're playing football and you kick the football along the ground, ball is going along the ground. Will it stop? Right? So as per Newton, it should never stop, right? Okay. That is the inertia of motion, because if the ball is in motion, it don't want to stop, right? So, but it is not practically happening, right? Ball will stop. Right? So how that is happening? So the Newton said that ball will remain in motion as long as there is no external force applied on it. So when we actually in practical scenes, when the ball is rolling on the ground, there are some forces, opposing forces are involved in that, right? Like a frictional force or air resistance, etc. All those forces are there, and it is actually trying to stop the ball, right? So yes, obviously it is going to stop. But Newton is also not wrong. Newton, what he said, that ball will stop in the motion, right? It will stop. It will remain in the motion unless external unbalanced forces acted on it, right? So friction is external unbalanced force. Why we are seeing unbalanced? We have seen that initially, that if let's say this is the frictional force, there is no other force acting on this from this side, right? So there is only one force, so we can say yes, it is unbalanced force. So it is the cause which is actually stopping the ball. Same thing happens with the cyclist. There is a friction between the tire and the road, right? So if there is a friction, cycle is going to stop. But cycle actually don't want to stop. That is the called as inertia of the motion, right? It don't like to change its own state. So, but that friction is the external force, and it is forcing that cycle to stop somewhere. So obviously, if you want to keep riding the cycle, you have to give it some energy, which this person is obviously giving by pedaling that cycle, right? Right. That's right. So this is the inertia of motion, you can see. Right. Then we have inertia of the direction. Right? So inertia of the direction. So we have seen inertia of the rest, then inertia of the motion, and inertia of the direction. Now, what is the inertia? Very funny video. We can. Not a funny actually. That person is flying, right? So it may have been hurt him, right? Okay. So what is happening? As long as I can see here, there is some racing event is there. and that person is going like that, right? And that bike, instead of going on the road, so obviously he must have turned trying to take the turn over somewhere. So this road must have some turn there, but that bike don't want to change its state of motion. It is in motion obviously, and also the direction. So bike is trying to resist the change in direction. That is called as inertia of direction. Therefore, if the bike is not changing the direction, then obviously he is now flying here, right, in the air. It's not like that we cannot apply the force to change the bike's direction. The bike has a handle, right? So it is not difficult to do that. Also in this case, also second example, also you can see that small toy car is there, and toy car is also not does not want to change the direction. Okay, so this is the inertia of the direction, you can say, or change in the opposition of the direction. Okay. Then now let's see. Next, mass is that quantity which depends solely upon the inertia. Right, I told you that the object with which have a lot of mass will have the lot of inertia as well, right? So that car we have seen, which is on the truck, has a lot of mass, therefore a lot of inertia. It didn't want it to change the state of motion, right? Okay. Now let's talk a little bit about the different types of forces we are going to see. So first of all, there are four fundamental forces actually, right? So whenever we study the forces, remember these four fundamental forces are very important. First force is called as gravitational force. Then second is called as electromagnetic force. Third is a strong nuclear force. And fourth one is weak nuclear force. Remember, these are called as the four fundamental forces. What are the other forces we do know? We know the friction force, right? We just seen that force in the previous slide. So friction is one of the force. Yes, gravitation you must have heard somewhere. And what are the other forces you know? The force between, let's say, electron and nucleus, right? There is an electrostatic force, or two charges, we can say any two charges between proton or electron or proton neutron. There is an electrostatic force, right? So these are the different forces, you can say, which are acting on the bodies. But all those friction forces or electrostatic forces are nothing but the small types of these all forces, right? Which are called as main four forces we have. That is gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force, right? So if I ask you which will be the strongest force in this case, right? You will say yes, sir, it is a strong nuclear force. Yes, simple. The name suggests it is the strongest force. Yes, that's right. Then let me ask you one thing. Which one is the weakest force? Yes, again, you will say that weak nuclear force is your weakest force. But now this is wrong. Remember, always remember, this is going to be in your entrance exam, or maybe in 11th and 12th, not now, obviously, right? But remember this concept, gravitational force is the weakest force found in the nature. This is the weakest force found in the nature. Now you will see how it is possible that Earth is attracting every object, right? We know that Apple also was attracted by the Earth actually. Apple was supposed to fall on the Earth, but Newton was in between, we can say, right? So therefore it falls on the Newton side. So Earth is attracting every object. How it could be the weakest force? So now when we say gravitational force, the formula for gravitational force is this one, G m1 m2 upon r square. This is actually the gravitational force, you can say, right? So no, this is not the force of the earth, we can say, per se. This is the gravitational force, is the force between any two objects, you can say. It could be any two objects. Now in front of you on the table, you can see there is a small book is kept there, or let's say mobile is somewhere, right? You must have laptop in front of you. So laptop and let's say your mobile, right? Those two objects also have the gravitational force in between them, right? But tell me, are they attracting each other? No, obviously not, right? There is, you cannot even see the attractive force. They are not coming closer to each other, right? But yes, the gravitational force is there. As they are not attracting, therefore we are going to say the gravitational force is weakest. Why it is weakest? Because here you can see one term which is called as G. Now this G has the value of 6.67 into 10 raised to minus 11 into m1 m2 upon r square, right? So you can say there is 10 raised to minus 11 means what, right? 10 raised to minus 11 means 0.0000000, right? Almost 10 zeros are there, then after there is 6 is 7, right? So it's a very, very small value, you can say. So therefore we can say that gravitational force is weakest. Then now how earth can attract the object if the gravitational force is so weak? Because earth is a very massive object, we know. So that force is also dependent on this mass, and we know the mass of the earth is how much, right? Mass of the earth, remember this part, is 6 into 10 raised to 24 kg. This is the mass of the earth. Now you can say 10 raised to 24 and 10 raised to minus 11. If you know how to do this calculation, that will be very right, very good. So 10 raised to 24, 10 raised to minus 11, if the bases are same, so actually it will look something like this. Into 6 into 10 raised to minus 24. This m2, let's say mass of the object, it could be anything, apple, let's say, right? Apple's mass is anyway very less compared to Earth's mass, so we don't worry about, don't have to worry. Now 10 into 10, the base is same. Let's not do this calculation, let's keep it as it is. So 10, base is same, add the powers, we know that, right? So minus 11 plus 24, how much? 13 m2 r square. Okay, so this is how you can say 10 raised to 13. Now that number has become very large, right? So now if the number is very large, then yes, you can see there is some force, and that force is going to act on that object. It could be an apple, right? Okay, so this is why we can say gravitational force is the weakest force. But also remember, gravitational force has an infinite range. What is the meaning of that? So for that, we have to consider this nuclear forces. Nuclear forces means what? Obviously, we can say which are related to nucleus, or in nucleus we can say. So if the proton neutron has some force between them, right? We already, electrons are anyway moving outward out of the nucleus, and proton and neutron are inside the nucleus, they will have some nuclear force. And we know the size is very, very small of that nucleus. We cannot even see the atom. Nucleus is very much smaller than atom, right? So what we can say that this range means up to how much they are acting, only the size of nucleus, very small, right? So almost the range is only 10 raised to minus 15 meter, right? This is the range of the strong nuclear force, though it is the strongest force, but still actually it's effective only for this much of a range. 10 raised to minus 15 means how much? Again 0.00, many zeros are there, so you can imagine how small range is that, right? And gravitational force have an infinite range, very long range, obviously. So even you can see the between sun and our earth, there is which force? There is a gravitational force. Then only our earth is actually moving around that sun, we can say, right? Okay, and range is very high, and obviously force is the weakest. But again, the mass of the sun, mass of the earth, if you consider both of the things, then obviously we can say that force will be again greater, right? Therefore, actually, earth is moving around the sun, we can say, due to the gravitational force of attraction, right? Then, now let's see what is electromagnetic force. Obviously, electromagnetic means, as the name suggests, there will be two types. Let's say one is electric, other one is, let's say, magnetic. Right? Electric means, let's say, between two charges, two protons or two electrons, or one proton, one electron, there will be a force of attraction, which we can call it as electric force of attraction. Magnet means, you already must have studied or seen some magnet like this, with the north and south pole, right? It is also going to attract, let's say, another magnet or ion. Okay, so this is the magnetic force, and another one is the electric force, you can say. Okay, so this is the second type of the force, electromagnetic force. So again, remember that it is more stronger than gravitational force, right? Also, it is stronger than weak nuclear force, but not as strong as the strong nuclear force, right? Third force is the strongest force from in the nature, we can say, right? And let's talk about the strong nuclear force. We already know now that it is between the particles which are in the nucleus, let's say. And what about the weak nuclear force? Weak nuclear force is actually, it is responsible for the decay, right? So weak nuclear force is actually responsible for the decay of particles or elements, we can say. Okay, that's it. So these are the four fundamental forces we are supposed to see. Then before going to the questions, so let's see what we have. Yes, it is a statement of first law of motion. So first law actually states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of external force. We already seen that inertia of rest or inertia of the motion. So if the body is in motion, it do not want to change, right? So, or if the body is in rest, then it will always remain in rest unless we apply external force. That is the necessary condition of business. So same thing. So first law, Newton's first law, or you can also call it as a law of inertia, right? Says every object will remain at rest or in uniform motion in a straight line unless compelled to change means forced to change, right? Or it is changed by some force, we can say, right? Compelled to change its state. State means what again? State of rest or state of motion, you can say, right? By the action of external force here. Okay. Okay. So now let's see some questions on this. So why does the man getting off the moving bus fall down? Right. So normally what happens? Many people try to. So this is the bus. Consider, right? Many buses have the open door like this, right? So some people even try to get off the bus even when the bus is actually moving. Right? So if the bus is motion, this person, let's say, trying to get off, but he falls down. Right? So it is not obviously it is not a safe. So we should never try that, right? So never try to get off of the moving bus. So this man, if he's trying to getting off, he will fall down. Why he is falling down? Right? This is, we can say, something related to inertia of motion. When the bus is in motion, right, that person is also in motion. That cat example we have taken, cat is looking at the at rest, but actually as the car is moving, cat was also moving. And as I say, if the driver applies the brake, suddenly what will happen? That cat will fall back, right, in the car. Same thing is going to happen here, right? Bus is in the motion, then we can say that person is also in the motion, right? So when he steps on the ground, so suppose this is the ground, and if his feet touches the ground like this, what will happen? As long as he is in the bus, his total whole body is moving. But when he touches the ground, his feet touches the ground. What is going to happen? His feet is going to be at rest, right? And upper body is going to be in the motion, right? Why? Because of the inertia of the motion, right? So let's see which option is correct. Oh, he falls because his habit of leaning forward. No, this is not true. Due to inertia of motion, the upper body continues to be in the motion in forward direction and feet comes to rest as soon as they touch the ground. Yes, this is the correct option, right? Like this. Others are obviously not correct. So, right? Let's see the next one. Why do the passengers in moving train suddenly feel a jerk in the forward direction when the train stops abruptly? Right? So again, you can see the same thing. So moving train is there, and train stops abruptly means it applies the brake suddenly, right? So again, we can say when the train was moving, the body of the passenger is moving, right? And when the driver applies the brake, what will happen? Upper body of the passenger continues to be in the state of motion and the lower part of the body is in contact with the seat, right? As seat means train is stopped now already. Abruptly means suddenly it stops, right? Then the lower part of the body will be at rest and upper body will be in the state of motion. So again, that is the reason why we are feeling the jerk there. Next. So this is the first law of motion we have already seen. So it deals with the what? Inertia of the rest, we can say, or inertia of the motion. Okay. Right. Let's solve one question on this. Which of the following statement is true about the inertia? Right. So first, let's see. Inertia is the property of body by virtue of which body is unable to change by itself the state of rest. Right. Let's say second one, inertia is the property of body by virtue of which body is able to change itself from the state of rest, right? We know that it is not able to change. Inertia is the property of the body by virtue of which body is unable to change by itself in the direction of motion, right? So first we can say body was at rest and it was unable, that is inertia, that's true. But we can say this is our inertia of rest. Then inertia is the property of body by virtue of which body is unable to change by itself direction of motion. Direction of motion, we can say inertia of direction here, right? It is not able to change the direction. Therefore, we can say this statement is also true and it is the inertia of the direction. Then inertia is the property of body by virtue of which body is unable to change by itself the state of rest or uniform linear motion. Yes, this is also true because it consists of the inertia of the rest and this is your inertia of motion. So both are there, right? So this is correct, we can say. Next, what will happen if the force is applied to body along its direction of motion, moving with a constant speed along a straight line? Right? So consider if you keep one object here and let's say if you are applying some force on this, right? So initially body was moving with the constant speed, right? And if now you are applying some force on that along its direction of motion, so if the body is already moving like this, you are applying the force in its direction of motion in the same direction, obviously, right? What will happen? Obviously body is already moving, you are again applying some force, so it will not stop, obviously, right? So then what will change, or can direction change in this case? No, you are also applying the force in the straight line, so direction will not change. So let's cancel this option. Will the speed change? Yes, it will change. Why? Because remember, force is nothing but, let's say, mass into acceleration. So when we say we are applying the force, can I say we are applying the acceleration also? Yes. So if we are applying acceleration, what is the job of acceleration? If in the same direction, acceleration increases the velocity or let's say speed, right? Then momentum decreases. Now we haven't studied about the momentum, but remember momentum's formula is equal to mass into velocity, right? So if the velocity is increasing, force will also increase, right? So this is also wrong. Continues to move with uniform velocity, no. Speed is increasing. So speed increases means velocity will also increase, right? Simple. Now let's as linear momentum, right? Last question has the mention of this momentum thing, right? Momentum, linear momentum, both are the same things, right? So very simple. Consider how difficult this is to stop a moving object, right? It is called a, let's call this term as a linear momentum. So consider if you want to stop, let's say bicycle which is running on the so on the road, we can say, right? So if you want to stop it, you can, right? Obviously it will be hurt a little bit, but obviously you can stop the bicycle by applying some force. It's not that difficult. But consider if you want to stop the car which is moving, right, with a lot of speed, right, then it is not going to be easy. You cannot just stop it, right? It will require some Hulk, right? Hulk can stop that car, not us. Not us human beings cannot, right? So why it is happening like that? Because we can say that momentum of the car is very high compared to momentum of the bicycle. So is it dependent on mass? Yes, it is dependent on mass, but not only mass, you can say. It is also dependent on the velocity with which that object is moving, right? So obviously bicycle will not have that much of speed, but car is going to be a very high speed will be there, right? So also you can take one another example. Consider the let's say if you are playing the cricket, in cricket, if the batsman hit the ball with a very high speed, you are very, let's say you are fielding near to the batsman, right? If it hit this ball very hard, what will happen? It is really difficult to stop that ball. But if just played it, if the batsman just pushed the ball a little bit, velocity is very less. Right now, it is not going to be that difficult. But to stop the hard-hitted ball is going to be difficult and harmful also, right? Because velocity is high. So velocity is high, therefore we can say momentum is high. Because this momentum is not only dependent on the mass. As we said that the mass of the ball was same in both the cases, but velocity is changing, right? So momentum's formula is equal to, we can say, mass into velocity. Here you can see this first object will have momentum how much? Very simple calculation is there. 3 into 2, right? It is 6. Here 2 into 3, again 6. Let's say 6. Okay, what will be the unit? Unit will be kg meter per second. This is also 6 kg meter per second. So even you can see both the ball have the different masses. Still their momentum will be same. So when they collide each other, it's not like that a bigger ball will destroy the smaller ball. No, they will affect each other with the same effect, we can say. There will be same effect after collision. Why? Because momentum is very is same, right? Okay. So even the smaller ball is also going to do same damage to the bigger ball, right? Because the momentum is same. Simple. So this is the concept of momentum. Okay. So this is the let's say introductory session of our chapter of the laws of motion. Here, the important concept we studied is only that law, inertia laws, right? So three laws are there: law of rest, then what is the law of motion, and law of direction. Sorry, not law. Inertia of state, inertia of rest, inertia of motion, and inertia of direction. Three things we have seen. Then the Newton's first law is also based on that part, right? That object which is at rest or in motion will stay at rest or in motion, state of rest or state of motion, unless compelled by external unbalanced force, right? That we have seen in linear momentum. So only hardly we have seen the 4 5 concepts are there, and the fundamental forces we have actually seen. Those 4 forces you can remember, that will be useful for in the future actually, right? Okay, so anyway, so we will continue this chapter in the next session. We are going to see the what are the other laws of the motion, and all those things. Okay. Anyway, so if you do have any questions on this part, please put your question in the forum. So I will try to answer them ASAP. Okay. Good. Sure. So we'll stop here. Thank you very much. Have a nice day.